Arithmetic with scientific notation.
Scientific notation is usually used to represent numbers that are, in absolute value, very large or very small.
Hello and welcome, scientific notation. As you see here, this very large number is going to be written in this nice format, nice called scientific notation, and I will explain to you how we are going to be doing that. This is called the coefficient, this is the base 10, and that's the exponent. This one here is a very small number, as you can see. It's going to be written in this nice way. It's called scientific notation. Coefficient, base, and the exponent. So when the number is very, very large in absolute value, the exponent will be positive. When the number is very, very small in absolute value, like this one here, the exponent will be negative. And then we will see how that goes now. The scientific notation is of this form. It could be a positive or a negative number. A times 10 to the power n. A is between 1 and 10, a greater or equal than 1, but less than 10. This is called the coefficient, excuse me, and it's a decimal number. 10 is the base, it's not going to be changed. And n is the exponent. It's an integer that can be negative or positive. Here's something to pay attention to. Only one digit to the left of the decimal point is allowed. Only one. And this digit should not be a 0. It should be 1, 2, 3, up or to 9. Here are, let's see which of these numbers are written in scientific notation. This one is, yes, written in scientific notation. This one no, because I have 2 digits here. This one is okay. I have only 1 digit. It's a negative number. This one is fine. This one is not fine. It's not a scientific notation because this here is not allowed as 0. It's not allowed. It has to be other than 0, 1 digit. So we need to remember these rules. 10 to the power m times 10 to the power n is 10 to the power m plus n. So when you're multiplying these two powers, you add the exponents. When you divide, you subtract the exponents. And 1 over 10 to the power n is equal to 10 to the power negative n. We'll see those who are going to be using them. Now let's see how to convert a decimal number to a scientific notation. Case 1. When the number is greater or equal than 1, you will end up having a positive exponent. So this is my number, and I want to turn it into a scientific notation. Now, imagine you have a decimal point here, and this decimal point needs to be moved all the way to here. So each time you move it one position, you're dividing by 10, 10, 10. So once you reach this point, you divide it by 10 to the power 7. So you divide it by 10 to the power 7, you have to multiply by 10 to the power 7 so it doesn't change the value of the number. So this is the number now after we divide this by 10 to the power 7. 10 to the power 7. So this is we normally don't leave these zeros here. So it's 3.47 times 10 to the power 7. That's the scientific notation for this large number. Let's take this small number between 0 and 1. This decimal point is going to be moved all the way to here. So each time now I'm multiplying by 10. Each time 10, 10. So once I get to here, I multiplied this number by 10 to the power 9. So I have to divide by 10 to the power 9 so it doesn't change the value. So you get this after you multiply this by 10 to the power 9 over this, and we use one of the rules. This will be 10 to the power negative 9. So 4.76 times 10 to the power negative 9. Now, converting scientific to decimal is easy. You have to multiply this by 10 to the power 7, which means you need to move this to the right 7 positions. Okay, so you are adding 5 zeros. Here you are taking this decimal point and moving it to the left 8 positions. And since you have already a 1 here, then you add 7 zeros to the left and you get the answer. If you want to convert a negative number, ignore the sign, convert the number without the sign, and then add the negative sign. Adjusting the exponent, we will see shortly. Sometimes when you are adding or subtracting or multiplying scientific notations, numbers, you end up having a number that is not in scientific notation. You need to adjust the exponent. So here's a situation here where this is not in scientific notation, so I have to divide this by 10, and then in order not to change the value of my number, I have to multiply by 10. So when you do that, you're moving this 1 position to the left and you're adding 1 to the 7 here. This is 10 to the power 7 times 10 to the power 1. There's a 1 here. It gives you 2.8305 times 10 to the power 8. Another example. This one here, I need to move it to the back 2 positions. So I'm dividing by 10 to the power 2. In order not to change the value, I have to multiply by 10 to the power 2. So now those are going to be added. So I'm adding 2 to this power. I get this answer. Another example here is to the power 7. Now I'm going to move this to the right 4 positions. See? 1, 2, 3, 4. So I'm timing this number by 10 to the power 4. In order not to change the value, I have to divide by 10 to the power 4. Now, which means this number here, this decimal point is moved to here, then I have to subtract 4 from 7. 7 minus 4, 7 minus 4. Another example, same situation. I'm going 1, 2, 3, 4, 5. So multiply by 10 to the power 5, I'm dividing by 10 to the power 5. So now, again, this will be subtracting 5 from minus 4, minus 4, minus 5, gives you minus 9. Now, if you are moving the decimal point to the left, your exponent is going to be increased. If you move the decimal point to the right, your exponent will decrease. Okay? Now, how to add or subtract 2 numbers in scientific notation? We have 2 cases, same exponents, that's an easy one. You add or subtract the coefficient, keep the exponent, convert to scientific notation if needed. So here we're adding these 2 numbers, so I'm going to add the coefficient, and here's 1, keep the exponent. This is more like the distributive property. This times this, plus this times this. Add, and we're done. No other thing needs to be done here. Another example, add. Now I get a number that is not in scientific notation. Remember, I need to move this to the right, to the left, I add 1 to here. Okay? Here, another example with negative exponents here. The same thing. Again, that's not in scientific notation. If I move this to the left 1 position, I have to add 1 to this. Add 1 to this becomes minus 3. Here is subtraction. Same thing. Subtraction. Okay. Now adding, subtraction, more examples. Okay, now here is not more example, that's a more case number 2, different exponent. So you have 2 methods. Method number 1 is convert the numbers to decimal numbers, add or subtract, then convert to scientific notation. Method 2, adjust the exponents and then add or subtract. Here, you can't add these two together. You have two different exponents here, so you can't really add them directly. So I can change this to a decimal number. Look, when you're multiplying by 10 to the power 6, you're moving this decimal 6 position to the right, which means you're adding 3 zeros. Here you're adding 2 zeros. Add them, and now you get this as an answer. Now, if I want to use method number 2, I normally use the smaller of the two exponents. Okay, you can do the other way around. We will give you an example later on, but it requires an additional step. So if I take the 4 here, I want to make this 10. I need to make this 6, the same as this 6. So this number needs to be divided by 100, and this has to be added 2 to this 4. See, we move this decimal point 2 positions to the right, we increase the exponent by 2. Now you have the same exponent. Let's just add these two numbers, you get the answer. Another example, okay, turn them into decimal numbers. Now we need to convert this to a scientific. See, we're moving to the right now. 1, 2, 3, 4, 5, 6, 7. So 10 to the 4. No, 1. Let's go back here. We did too far. 1, 2, 3, 4. 4. So 5.7823 times 10 to the negative 4. Okay. All right. So now here, this one here. Now, if I need to do the smaller of the two of these numbers is this, so I need to make this negative 4. So I need to add 2 to this, which means I'm moving this to the left, take 2 positions. Now you can add these two numbers, and you get this the same answer. Okay. Different exponent. Another example. More examples. Here, subtracting. You can't do this subtraction right away. This has to become 6. So I need to add 2 to this 4. So I move this position 2 positions to the left. No, this is first. The method number 1 now is decimals. Okay, this is changed into decimal number. This one decimal number. Subtract. Turn it back to a scientific notation. Now, if I take this 4, I need to make it 6. So I move this 2 positions to the left and increase this by 2. I get this. Now you have the same exponent. Subtract, and you get this answer. Multiplying two numbers in scientific notation is a lot easier, because all what you have to do is multiply the coefficients, add the exponents. Remember, this is the only time where we add the exponents, is when you are multiplying the powers of 10. And then you convert to a scientific notation if needed. Let's see, I'm going to multiply these two numbers. So I multiply the coefficients. Look what happened to the exponents. 4 plus 3, 4 plus 3. You get this answer. Now this is not in scientific notation. I need to move this 1 to the left. I increase this by 1. Remember the rule I mentioned earlier. Another example, the same thing. You multiply these two numbers. Minus 10 plus 6 is minus 4. Now this is not scientific notation. Move 1 position, add 1 to this. Okay? Dividing two numbers in scientific notation, it's you divide the coefficients, subtract the exponents, convert to scientific notation if needed. Here, you need to divide this by this, so divide the coefficients, time 8 minus 3, 8 minus 3. Give you this. This is not in scientific notation. Now I'm moving this to the right, I have to reduce this. Remember the rule. Move this to the right 1 position, reduce this by 1. Another example, again, divide this time. 10 to the power negative 3. Negative 3 minus 10. Be careful, minus 10 becomes plus 10. Plus 10 minus 3 is plus 7. So you get this times 10 to the power 7. Again, is not in scientific notation. Move this to the right 1 position, you reduce this by 1. Now I'm going to give you many examples so you can understand what we're talking about. We're going to be adding these two numbers. They don't have the same, the same exponents here. So first we are going to change each one of them into a decimal number and then turn it into a scientific notation. Method number two, need to make this 5. So to increase this, I have to move this to the left one position. Now you have the same exponents. You just add these two numbers, you get the answer, same answer. Okay, now example number 2, I got some technical problem here. Example number 2, before I need to remind you, every time you see this picture here, you can pause the video, solve the problem, and come back and see your answer, compare your answer. So now we are calculating these multiplications here. So you can do, first you can multiply this 50,000 by this here. You get 320,000 times 10 to the power negative 6. So this gives you 0.32, 0.32. That's not in scientific notation. When you multiply this by 10, you subtract minus 1 here. Okay, so 10 to negative 1. Or what you can do, you can take this 50,000 and turn it into a scientific number. And now you multiply 5 times this gives you 32. You add the exponent, negative 2. You get this one here. Again, in scientific notation is this. Example number 3. We need to calculate this this subtraction here. Now you have here the same exponent, so you can really do this minus this and keep the exponent. But if you want to do to turn them into decimal numbers, it's not really needed. It's a longer, and you might risk making some mistakes here. So so you did this here, subtract, and then turn this into a decimal number. So you are going to the right 1, 2, 3, 4, 5, 6, 6. So you have to go back 6 minus 6. Okay. If I just because these are the same here, so I subtract the coefficients, 10 to the power negative 4. You get this answer. That's not in scientific notation. So I'm moving this to the right 2 position. Then I have to reduce this by 2. Okay. Example number 4. Again, subtraction here, not the same exponent. So turn them into a decimal numbers. Subtract and turn this into a scientific notation. Look, 1, 2, 3, 4. So I moved 4 position to the right. You can imagine that you have here 10 to the power 0, and that's why we are subtracting 4. Okay. Now, if I want to make this negative 4, so I have to multiply this by 10 to the power 2. So you move this to the left 2 position, you add 2 to this, you get this here. Do the subtraction and you get the same answer. Example number 5, the same thing here. Okay, I'm going to do the 4, make it into a 5. Now I need to get this 1 position to the left so I can add 1 here. Okay, and then you add the coefficient and you're done. Now, if you want to use to turn each one of this into a decimal, it's not really necessary. This is much easier here. So anyway, if you want to do it this way, that you can do that, and you get the same answer. Example number 6. Now, I'm going to add these 2 numbers. Now, as I told you before, we use the smaller of the 2 powers here, of the 2 exponents. But you can use the other one. I will show you what happens if you decide to do that. So if I take this 3 and I need to make it 4, so I need to move this to the left 1 position so I can increase this 1 by 1. Now you add these two, you get this answer. Now, if you decided to play with this instead of this, you need to reduce this now. You need to reduce this, then you have to move this to the right. Add these two numbers. Now, this is not in scientific notation. Now you have to divide this, go to the left 1 position, you add 1 to this, and then you get the same answer. Example number 7, division. So 8 divided by 4 is 2. 22 minus 7. 22 minus 7, it's 2 times 10 to the power 15. Example number 8, addition with negative exponent here. Okay, so here what I want to do, this is smaller than this, so I need to add 1 to this, so I need to move this to the left so I can increase this by 1. Now you can add these two coefficients and you get the answer. If you want to turn each one of them into a decimal number, you can, but be careful, you have to line up the decimal points here, add them, and then now this is going to go 1, 2, 3, 4, 5, 6, 7, 8, so 10 to the negative 8. Example number 9, division. Okay, 3.5 divided by 7 times 10 to the power, be careful, 6 minus 3. That's 9.5. That's not in scientific notation. I have to multiply this. When you move this to the right, you reduce this by 1. That's it. Example number 9, addition. Now this 7 needs to become 8, so divided this decimal point that is here, go to the left, and now you add the two coefficients and you're good. Example number 11, division. (3.5) divided by 7 times 10 to the power negative 6 minus 3, okay? That gives you 0.5 times 10 to the negative 9. Now this is going to go to the right. It's going to go to the right. It reduces this by 1. 5 times 10 to the power negative 10. Example number 12, multiplication. You multiply these coefficients and add 9 plus 8. Multiply, add. Not in scientific notation. When you are going to the left, you increase this by 1. That's it. Last example, multiplication again. Okay, multiplying the coefficient and add negative 9 plus 5. You get this. This is not in scientific notation. Move to the left, you increase this by 1. And that's it for today. Thank you and see you soon.
Thank you for watching. More videos to come. Please subscribe.